Hi everyone, welcome back to the workshop, and it's repair time again. And this time I've got a Keithley K2001 7.5digit multimeter. Now, I did repair one of these a few years ago and that turned out to be a bit of an epic. And I was kindly donated this one by Steve from the USA. So really looking forward to getting back into the 2001. This one's got a few issues, but hopefully we can effect a repair and bring it back to life. Now, Steve did tell me that he actually made a repair attempt on this unit himself, and he's provided quite a dossier, a full description of what he's done already, and all the schematics and some measurements he's taken from various points, etc. And on top of that, now he also provided a whole bunch of DigiKey parts, a test cable they made up, so hopefully these will come in useful during the repair. Now, I believe that Steve actually received the unit as faulty himself, and when he went inside it, he didn't see any leakage on any of the capacitors inside the unit, which is a very notorious problem for these units that causes complete havoc, but he replaced the caps anyway. He also replaced the fan, powered it up and did a limited DC voltage and resistance check, and it appeared to work correctly, but a calibration was needed. He attempted 2 calibrations and both failed, citing 400 plus section errors. And referring to some of the ex-dev's documents on repairing K2001s, he replaced a few parts, but it didn't cure the 400 section failures. So he fabricated a ribbon cable extender to raise the ADC board off of the main board so he could get underneath it. And then, a couple of days later, he lost complete power throughout the whole device. Now, he did check the output from the main transformer inside the unit, and it was still outputting some AC voltage. And that's about as far as he got. From that point onwards, he shipped it to me. So, first things first, let's take a look inside. Let's look over the unit before we even think about powering it up. Right, here we are inside the unit. We're looking at the analog board at the moment. The digital board's on the other side. We'll get to that. And you can see, just by looking around, you can see the electrolytic capacitors that Steve did replace. He said he'd replaced them all. So yeah, there's evidence of that. There's some sealant there just to stop them wobbling about. You've got the A to D board over here, and you've got the power supply circuit over here, the AC main side with that notorious 120 volt, 240 volt auto selection. Everything else looks okay. There's no evidence of anything blown. One thing I will need to change out is this resistor up here. That's a temporary solution that Steve made because the original resistor went open circuit, and it's meant to stand vertically off of the circuit board and clamped against the case with this little clip here because it does get warm. So we will need to replace that. I do have some of those. And also the fan he changed out for a slightly different model. It's actually slightly wider than it should be. I'm going to change that back to the original fan. I do actually have a fan in the K2001 parts bin that I've got, which I'll show you right now actually. So here is my box full of K2001 parts. A lot of it from the original K2001 that I actually repaired. So here is digital board. I never actually used this one. You can see that I'd started removing some parts, so yeah, that one won't be much good for anything. We've got the analog board here, and I do know that every single IC on this board's about blown, because this is the board that the secondaries went haywire, went way over voltage, and just basically blew just about every IC on the board, and if you measure across the supplies, they're all dead short. And from there I've just got a mixture of parts, some ICs that I'd replaced on the digital board on my own unit, some other random parts here, a front panel from the blown unit, and this one actually has a faulty microcontroller on it. I think the supply in that one affected that. We've even got a case and an A to D board here. This A to D is again subjected to that wayward secondaries, so it is absolutely dead shorted and probably all blown up. But interestingly, like what I mentioned, I do actually have an original fan, so I'm going to fit that one onto the unit eventually. Here's the digital board. Everything looks pretty reasonable actually. Don't see too many problems at all. The only thing is this capacitor here, which I believe Steve replaced. He didn't have an axial obviously, so he's fitted a radial and just extended one of the legs down and round and down through the hole. Not ideal because it does extend that ground connection, the length of the leg there. If I've got one that I can replace it with, I'll just go ahead and do that just for completeness. Otherwise, everything else looks okay. We've got the little inverter board here, that looks intact, and we've got a Dallas non-volatile RAM, so I might change that out for a FRAM IC as well, because I do actually have a few FRAMs in stock. So back to the analog board. First things first, let's remove the analog board from the chassis. So with the board out, I can get a closer look, and there is that resistor that Steve actually replaced with some generic one, so we will replace that one. I definitely got one of them in stock. Now, as I said, he did replace the capacitors, but he also replaced like a voltage regulator and some other bits and pieces, so we will try and take a look at that before we power it up. But I'm going to get on with the main stuff first, and that is this resistor here. Let's clean up the heatsink compound that's all over the place here. Now I do actually want to check out the transformer as well. So like I said, he just said it lost all power at one point, and that's where he stopped. So we will need to check the secondaries here just to make sure they're okay. But wait a minute, spotted something already. I just turned the board over again, and look at this dirt or some marks anyway in and around some of these transistors, and I spotted an unsoldered joint on this relay here, and it's definitely a pin that's used. You can see that big track coming off of it, and that pin is flapping about in the breeze, so I wonder if that's the source of losing all power. But I'm a bit more concerned at the marks in the PCB. Actual fact, it's not dirt, it's actually the top solder mask, which has actually been worn away, and I wonder if that's the result of being a little bit too zealous with the desoldering gun. And similarly over here as well, you can just see it's a little bit of a mess there. So wow, and you've got the side of this tantalum capacitor's got a little bit of a burn mark on it. That looks like it's from a soldering iron. Same with this one here. Let me turn it round. Yeah, look at the sides of those capacitors there. Definitely got burn marks from a soldering iron. So with that, before I go any further, I'm actually going to take this bottom plate off, this cover here, and let's have a look underneath. Okay, there we go. Now I'm being very aware not to touch the analog circuitry here. Don't want to contaminate the board with the oils of my fingers, but actual fact, it doesn't look too bad under there. I don't see any problems at all. Possibly actually, there is one problem. Was that under? Yes, it was. Looks like we've got some residue there, or again overzealous with the desoldering tool there, and it looks like it's marked the solder mask layer when these capacitors on the other side of the board there were replaced. So yeah, not ideal, but hopefully there's not a problem there. Well, there's my new resistor, but before I fit it, I have actually gone ahead and gone over quite a lot of those solder joints that had the solder mask damage, and just to give them a resolder there, a freshen up, just in case there was any problem there. The next thing is to replace, I'm going to replace 3 tantalum capacitors. They've all got burn marks on the side of them. And luckily I've got the exact tantalum capacitor required, perfect package, go straight on. Now, these capacitors are actually glued onto the PCB because they're on the underside, so it can prove a little bit of a challenge to remove. And the way I'm doing it is I'm just clamping the side of the capacitor and then just heating up one leg at a time with some slight pressure on the capacitor, probably a little bit more heat than normal, just to melt that glue. And there it is, and you can see the actual glue residue there and on the underside of the capacitor, so that'll need a clean up as well. So I'll go way off and do the other ones and replace them. It's just a way to clean up those pads there, ready for the new capacitors. And I just sort of took a look over the rest of the board on the underside there, and it's actually quite dirty. There is a thin film of dust or grime right across the whole board, and this is the sensitive analog electronics. So I think in actual fact I'm going to give this a brush down with some IPA, and let's just clean up the underside of that board there. You never know, it could be responsible for that 400 series errors that Steve was experiencing. And the technique that I'm using for this is, I've got my IPA there, and I'm just got my PCB brush, and I'm just going over the PCB directly with the brush, just try and dislodge any of that dust and grime. Of course at this point I'm just moving it around, but hopefully it's dislodged it. And then going over it with my cleaning sheets just to lift off that dirt and grime. Plenty more IPA to help it along its way. And that just helps lift it off the board. Then once it dries, hopefully it's a lot cleaner. There's still some little bits of dirt that I can see, so I'll probably need to make 2 passes. But I'll go over the rest of the board and then I'll come back. Spotted another little bit of an issue. This is a 8-pin device, an 8-pin IC through hole on the underside of the board underneath the A to D board. And again, it's just a bit of a mess in terms of the solder mask being sort of broken up, and yeah, and the soldering doesn't look too good either. So I don't know who was desoldering these ICs or these components off of this board, but yeah, it's a little bit of a mess unfortunately. So I'll resolder this one's up, same as I've done the other ones. In fact, this pin here just looks like it's got hardly any solder on it at all, so yeah. Okay, that's the board cleaned up as best as I can. And I've also gone ahead and fitted the large resistor there. And looking across the top side of the board, I'm not seeing too many issues. I've removed the A to D board just to have a look underneath, and it's looking okay under there. There's that IC there, LT1007, which had been desoldered, so that's a little curious. So with no other major issues, I think we can put this to one side and let's get the transformer powered up and let's just check out the secondaries. Now of course I don't really want to power up the transformer. It's slightly harder than normal, and that's due to the multiple primaries that are on it and that auto 120/240 selection. So I'm just going to use my ohmmeter on each one of the secondaries and the primaries, and just let's make sure they're intact and none of them are shorted out onto the case here. So first things first, the primary side, which is this down here, and we've got a brown and a brown white. 6.19 ohms, that looks okay. And no short out. No. And then we've got Black, white and a black. That should be a fairly low resistance. 3.14 ohms. Yeah, that looks good. And got the centre tap and the primary there, and this should be one side. Should be a larger resistance. Yep, 15.2. That side, 26.3 on the other side. They're quite far apart, those two. That's the centre tap. You've got 90 volts either side coming in there, so there's quite a difference there. Now this may not be a problem because the difference in resistance is down to the length in the wire. 15 ohms that side and 26 ohms that side, so the length of the wire might be longer for the identical number of turns if one is wound on top of the other one, so it might not be a problem. In this other transformer, it's getting slightly different readings, but not as bad as this one, or not as wide apart as this one. And they are both TR280 Rev D, but as you can see, one of them looks a little bit different to the other one. So one's probably a lot newer, or just wound differently. Different codes and all the rest of it on it, even though it's down as a TR280 Rev D for both. So I'm just going to go with the original one. I'll be powering up rather carefully anyway, so shouldn't be a problem. Okay, I'm just about ready for a power up. I'm not connecting up the secondaries, but I do have the primary side header plugged in with all its various taps there, because I can power up in this state here and monitor at least partially this section over here with the 240 volt 120 volt selection, the automatic selection, because it's controlled locally on here, but I won't be able to monitor the control signal for the MOSFET and this resistor here because it comes from the digital board. But at least I can power up at 110 volts here and just do some probing around on this header here and just have a look and see if it sort of matches with the partial hookup I've got. This is quite a complex and quite a novel, and some would say it's the worst thing ever, is the automatic 240 volt 120 switching regulation circuit and the high-low for that 220 to 240 control that's required. So I'm going to actually refer back to my original K2001 repair, where I actually analysed and went over that circuit in detail and showed exactly how it works. So I'll bring that up now and then we'll come back here. Okay, so here's the power supply circuit and the primary side of the transformer. Down at the bottom left here, you've got the mains switch. It's a hard switch, and you've got the AC live and the AC neutral. And straight away, if you follow up the AC live, you'll see it doesn't go to the primary side of the transformer directly, which is over here. It goes onto one of the AC sides of a bridge rectifier. The other side of the bridge rectifier, the other AC side, actually comes down here, goes away through some relays, more about that in a minute, and then into one side of the primary side of this transformer. The other side of that primary side then comes back to the neutral side. So effectively, the bridge rectifier here is in series with the primary winding of the transformer. How can that work? Well, Marco Reps did a Keithley 2001 repair on his channel, and his little gem of information regarding this resistor here and this FET here gave me the information that I needed in order to work out how this was working. So your live comes up here, your AC live comes up here and into one of the AC inputs on that bridge rectifier, as I mentioned. Now, if you imagine that none of these components here are fitted, there's no MOSFET, there's no resistor or anything connected to the positive and negatives of that bridge rectifier, then when the AC comes up on here, the positive side is going to conduct onto this through this diode here and just stop there. It's not going to go any further. The negative side is going to conduct, and it's going to stop at this point here as well. Nothing's going to happen. You're certainly not going to get anything coming down and along towards the primary side of that transformer. However, this resistor is the key. So you can see that this resistor here basically connects between the positive side and back onto the negative side. So with that connected, you can imagine your AC current's coming up through here. It conducts down through here, the positive side, goes away through this resistor and back and down through this diode, and then onwards towards the primary side of the transformer, and basically the opposite side for the negative going voltages. This 470 ohm resistor is basically your bootstrap resistor. It gives just enough current to flow in order to get the transformer working and to produce some sort of secondary voltages, at which point a control mechanism starts up. And this is where the MOSFET and this photocoupler come into action. So there's a control signal that comes up here through this photocoupler and onto the gate of this MOSFET. The amount of current that flows through the MOSFET is controlled in order to regulate the primary side current and therefore the secondary side current. Now we also have some relays here that I mentioned earlier. Basically one of them takes care of the 220, 110 volt selection, basically selecting different taps on that primary winding, and you've also got a high-low control relay here and here. And I think that's just used to enable in the extra turns required going from, for instance, 220 to 240 volts. So how does this 220 volt, 110 volt operation work? Well, the relay here, the main relay involved, is driven from positive relay 1, and the other side of the coil is actually grounded. So let's take a look at where this signal comes from. And here it is over here. And what you've got is another secondary winding coming into a bridge rectifier. You've basically got an LM317 producing an 8 volt supply and a MOSFET here basically controlled by a comparator. One side of the comparator here, the positive side, is basically 2 resistors, a voltage divider, so you've got 4 volts at the positive input of that comparator. The negative side of the comparator basically comes from ACL. ACL was on the first schematic I showed you. That was your AC live. That's your 240 volts live connection. So you've got a large dropper resistor here and a bit of rectification, a smoothing capacitor here, and I'm presuming at pin 3 you're going to get more than 4 volts when you're using 240 volts, and it'll go below 4 volts when it's set to 110 volt input. Therefore, the output of the comparator is basically going to turn this MOSFET off and on. Therefore, the relay is turned off and on. So back to the first diagram, here's that 220, 110 volt relay, and you can imagine if there's some problem with the signal here coming from that other schematic driving this relay, or if there's a problem with the relay itself, you could theoretically have 240 volts coming through on the 110 volt side of this primary winding here, and basically over voltaging the secondary side. Okay, ready for a power up. So I'm going to go across the primary side of the transformer, and I'm going to go across that center tapped white wire and 190 volt side. And I'm not sure what we'll get because I'm only putting in 110, and we're getting about 80 volts AC. And I'm not sure if you heard it, but when you first power up, I can hear an audible click on one of the relays. Let me just do that again. It's off at the moment. Let me put it on. Yep. Got a click there. So we've got 80 volts that side. Should be getting the same on the other side. Yes, we are. That's good. And let me just keep on that center tap there and go along the connector. This far end tap here, 97 volts. Okay. So that's the extra high-low, that's that extra 20 volts. That's okay, and I should be getting the same at this other end. Yes. So this should be the 80 volts. Yes. So the primary side of that transformer is intact. But what about the secondary side? Well, let me see if I can get onto that. It's not very easy. So first of all, this is the 8 volt AC tap, and I'm getting about 6.3. That's okay. And this one here should be about the same. It's 8 volts as well, 6.5. This is the power for the digital board. That's good. And then the center tapped secondary side. This is one side, 14.8, and the other side, 14.8. So across the two of them, I should get double that. Yep, 29.7. So I think the secondary side of this transformer are intact as well. So without the digital board, that's about as much as I can test. I can't test out the MOSFET in that large resistor, the 470 ohm, because the control for it comes from the digital board. So I think the next thing is to actually hook up the digital board and the secondaries onto the analog board and go for a full power up at 110 volts. Right, let's go for a power up. I've got the digital board powered, but I've left the secondaries for the analog board disconnected for the moment. So let's just power up and let's see if we've got anything on the display. Right, so let's go. Yes! Yes! Model 2001. We've got power. Excellent. That'll mean the 5 volt supply in the digital board's fine. Haven't measured it, but it probably is. So let's now plug in the secondaries for the analog board and see if that makes any difference at all. Okay, here we go. Yes! We've got power. And we've got something from the A to D on the display. So it looks like it's so far at 110 volts anyway, our power supply circuit's working. So now let's do a quick check on the DC supplies on both the boards. Okay, so hopefully you can see the multimeter there. I'm going to test the outputs from the DC side of the analog board, because there's a bunch of regulators and bridge rectifiers there. So the easiest place for me to pick up the minus 15 volt supply is on an op amp down here. So I'll just go on to that there and I'll switch on power. Minus 15 volt, that's good. And the supply to that op amp should be plus 15. Yes, plus 15. Perfect. Plus 5 I can pick up on the A to D board. It's clearly marked plus 5. Yep, 4.96. That'll do me. And there's also an unregulated supply and a voltage doubler. So there's two test pads here, a plus BS, 38 volts, and the minus BS is minus 38 volts. And that's about right, because it's a 17 volt supply without the doubler. Double that, you're roughly 38 volts. So it looks like the voltage doubler is working okay as well. So far so good. It seems to be powering up just right. I'd think at this point, well, that's it, put it back in its case and it'll be fine. But that's not the case. Remember, I'm running at 110 volts. So we're certainly not putting to task the automatic 120/240 volt circuit and the high-low part, and probably even the bootstrap circuit. So the only way to test that is actually to monitor the secondaries and then wind the voltage up slowly from 110 volts all the way up, and we should see the secondaries jump down when the voltage thresholds get above a certain level and the input primaries change taps. But I think that'll be for a second video. I think I've got enough for this video, but don't worry, the second video is going to be coming up quite shortly. This is on the workbench and I'll be carrying on. So thanks for watching, and remember, you can always comment down below. What did you think of the repair so far? Anything I should have done but didn't do? And how do you think it's going to go in part 2? Don't forget to like and subscribe, it really does help the channel grow. Links below to my website, and for those who prefer Odyssey, check out my channel there. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.